What if an AI could look at every pixel on your screen, understand exactly what it sees, and then act on it just like you would? Imagine snapping a screenshot, typing a simple instruction, and watching an agent seamlessly navigate your web browser, desktop applications, or mobile apps, all without you writing a single line of automation code. That's the bold promise ByteDance has just delivered with Utar's 1.5. No more wrestling with fragile CSS selectors, digging into hidden DOM trees, or piecing together cobbled together helper scripts that break at the smallest UI tweak. Instead, Utar treats your entire display as one cohesive image. It reads the visual layout, interprets your intent, and executes clicks, drags, text entry, or scrolls with human-like fluidity. You could automate everything from bulk renaming folders in Windows Explorer to populating multi-step web forms or even orchestrating actions in specialized CAD software, all with one natural language command. It almost feels like having a virtual assistant perched at your shoulder, ready to jump in the moment you need help. But of course, to pull off that seamless leap from sight to action, Utar must first see the screen clearly. So before we dive into its jaw-dropping benchmark numbers, let's peel back the curtain and explore how Utar's perception engine transforms raw pixels into meaningful insights. Because without that visual superpower, none of the downstream brilliance could happen. Think of it like trying to drive a car blindfolded. Utar removes the blindfold entirely. Beyond DOMs. Vision-first automation. Traditional automation tools, whether browser-based RPA suites or headless script bots, force you to treat every interface like a code problem. You hunt through nested page hierarchies, they define brittle element selectors, and pray they don't break when a developer renames a class or nudges a button by a few pixels. Utar discards that brittle paradigm and flips the script. It treats your entire interface as a single high-resolution image. Hand Utar a screenshot and a plain English prompt, and it processes raw pixels to infer layout, identify interactive elements, and understand context without ever glancing at the underlying code. This unified perception-to-action pipeline means you never update your scripts after a routine design refresh. Buttons move, Utar adapts instantly. Dark mode kicks in at night, Utar furrows no eyebrows. Even radical UI overhauls don't trip it up. Embedding visual understanding into its neural core gives Utar resilience that rivals human flexibility. For you, that means spending less time on maintenance and more time on the creative or strategic parts of your workflows. And while this vision-first philosophy may feel like wizardry, it's simply the foundation for everything Utar does next. Without seeing clearly, any action plan or reasoning step would falter just as badly as legacy tools. Now that we've seen why screen-level vision is a game changer, let's zoom in even further on how Utar builds that vision with a truly supercharged perception pipeline. Supercharged perception. At the heart of Utar's visual prowess is a meticulously assembled perception system. ByteDance ingested millions of diverse UI examples, spanning complex CAD layouts, professional photo editing panels, enterprise ERP dashboards, e-commerce checkout flows, and immersive mobile games. From this treasure trove, they distilled 5 complementary vision streams that operate in parallel. Bounding box detection precisely locates every UI element, down to tiny 10 by 10 pixel icons, so nothing gets overlooked. Dense captions weaves detected elements into a rich narrative paragraph, crafting a human-style description of the entire screen. State transition summaries annotates hover, focus, click, and active states to catch dynamic UI feedback like button highlights or subtle animations. Screenshot Q&A equips the model to answer ad hoc "where is" questions, "where's the download icon?" without rescanning. Colored marker prompts overlays synthetic color markers that map language tokens directly to pixel coordinates, guaranteeing pinpoint accuracy. By layering these streams, Utar achieves a multi-dimensional understanding. It doesn't just recognize a floppy disk icon, it knows it's the save button, understands the pop-up that follows, and anticipates the confirmation message. This holistic view, peripheral and focused vision, plus context and intent, forms the springboard for Utar's precise, reliable interactions. With that deep visual comprehension in place, the next challenge is, how does Utar decide exactly how to move the mouse or press a key? That brings us to its unified action space. Unified action space. Identifying what to click is only half the battle. Utar also needs a dependable set of primitives to interact with any GUI. Rather than juggling dozens of disparate APIs, Utar learns a concise action vocabulary that spans the full spectrum of desktop and mobile interfaces. At its core are 5 elemental moves. Click XY executes a precise mouse click at the given coordinates. Drag start end drags from one point to another, pulling down menus or dragging sliders. Scroll amount scrolls content by a specified delta value. Type text sends keyboard input with realistic timing. Wait MS pauses execution to let animated UIs catch up. Layered on top are meta actions. Finish to signal that the workflow is complete, and call your user to prompt for help when Utar encounters an insurmountable roadblock like a credential prompt. Desktop specific hotkeys, Control CV, Alt Tab, etc., and mobile gestures, long press, swipe, back button, round out the lexicon. The ByteDance team then normalized millions of recorded multi-step traces, from open-source web crawlers to hand-scripted Android sessions, into this unified schema. Utar learns to sequence these primitives into long horizon plans, often spanning 15 or more steps, opening nested menus, selecting precise options, filling out forms field by field, and verifying each outcome. A straightforward action vocabulary makes execution reliable, but choosing the right sequence in novel situations requires strategic thinking. Two-speed thinking, System 1 and 2. Human intelligence naturally toggles between two modes: fast, instinctive reactions and slower, analytical reasoning. Utar's 1.5 mirrors this dual-mode approach with System 1, reflexive clicks for familiar patterns, and System 2, chain-of-thought planning for complex or unexpected scenarios. To see this capability, ByteDance collected 6 million compact GUI tutorials, 3-step snapshot-based walkthroughs from across the web, then refined them with a large LLM filter to ensure clarity and relevance. During training, for each action trace, Utar generates multiple candidate thought action pairs, simulates them, and retains only the successful sequences. As a result, before executing a click, Utar literally talks itself through the task. Here's the file menu. Click that, choose export, select PDF format, then press save. This explicit meta-reasoning shines when tasks deviate from the training set: unanticipated dialogues, dynamic content, or novel layouts. A reflex-only agent might blindly click the wrong spot. Utar's chain of thought pauses to weigh options, anticipate roadblocks, and adjust its plan on the fly. By employing best-of-n sampling, exploring several reasoning paths in parallel, Utar picks the most promising strategy before moving forward. The outcome is human-level adaptability, immediate responses for routine actions, yet meticulous planning for anything unfamiliar. And when the unexpected inevitably happens, those internal monologues guide it back on track. Of course, even the cleverest planner can trip up, so Utar also learns directly from its mistakes. Learning from mistakes, DPO. Real-world UIs are far messier than any training dataset. Utar addresses this head-on with a blunder versus fix feedback loop powered by direct preference optimization, DPO. The ByteDance engineers spun up hundreds of virtual machines, ran early model versions through real GUI tasks, and recorded every misstep, misclicks, dead-end loops, validation errors. Human annotators then paired each erroneous action with the correct fix, crafting a labeled dataset of what went wrong and how to fix it. During DPO training, Utar's model receives positive reinforcement when it reproduces the correct fix and negative reinforcement for repeating the blunder, all while staying anchored to its stable, supervised baseline. After just a few iterative cycles, the 72 billion parameter variant vaulted from roughly 17 to over 24 points on OS World's 50-step benchmark. This real-world feedback not only corrects mistakes, but teaches Utar to proactively anticipate problematic scenarios, unexpected modals, asynchronous load delays, or missing elements, and handle them gracefully. In practical terms, that means fewer unexpected failures, minimal human intervention, and an agent that genuinely improves with every glitch it encounters. Errors cease to be roadblocks and instead become stepping stones for continuous refinement. But how does Utar's performance stack up against other leading agents? Let's dive into the benchmark showdown. Benchmark showdown. When it comes to direct comparisons, Utar's 1.5 leads emphatically across desktop, Windows, and Android challenges. In the synthetic OS World sandbox, the full model scores a 42.5% success rate in 100 steps, eclipsing OpenAI's Operator at 36.4% and Claude 3.7 at 28%. On the Windows Agent Arena, a more rigorous 50-step desktop gauntlet, Utar still dominates with 42.1% success versus a 29.8% baseline, showcasing its superior planning and error recovery. Mobile environments tell a similar story. The 7 billion parameter Utar hits 64.2% on Android World, compared to the prior high of 59.5%. In high-resolution professional apps tested by ScreenSpot Pro, Utar's grounding accuracy leaps to 94.2%, while competitors hover around 88%. Even in real-world minigame benchmarks, from Snake Solver to Infinity Loop, Utar clears every single challenge at 100% success, with others stumbling through half. These results aren't demos cherry-picked for effect. The ByteDance team published the full tables, scripts, and raw logs on GitHub for anyone to verify. This across-the-board dominance, spanning web browsing, desktop automation, mobile control, and gaming, underscores Utar's unmatched versatility. It's not a narrow specialist, but a unified agent that excels wherever a GUI lives. And perhaps most exciting of all, this powerhouse isn't locked behind paywalls or restrictive licenses. Open access and real-world play. The most refreshing aspect of Utar's 1.5 is its open source spirit. The 7 billion parameter checkpoint is available on Hugging Face under Apache 2.0, meaning you can integrate it into commercial products or personal projects without worrying about royalties. For those needing the full muscle, the 72 billion parameter weights are accessible via a simple research access request. Just email the ByteDance team with a brief project summary. Beyond the raw models, you gain the entire ecosystem: the unified action schema, screen capture toolchain, replay datasets, training scripts, and evaluation benchmarks. Keen to kick the tires? Download Utar's desktop application and type natural language commands to watch the agent drive your PC in real time. No GPT-4 subscription required. Whether you're automating financial report generations, conducting large-scale QA tests, or building accessibility tools, Utar's modular design scales to any GUI environment. And with continuous retraining on fresh traces, it remains resilient as your software stack evolves. By unifying perception, action, reasoning, and memory within one neural backbone, Utar ushers in an era where you simply tell your agent what you need, and it figures out the rest. No brittle scripts, no endless maintenance. We've journeyed from raw pixels to polished performance, exploring how Utar's 1.5 marries vision-first perception, a streamlined action space, dual-mode reasoning, and mistake-driven learning into one cohesive model. This agent adapts to UI redesigns on the fly, recovers from errors without human rescue, and consistently outperforms legacy setups, all while remaining fully open source. Now it's your turn. Which repetitive or complex workflow will you hand over to Utar first? Will you automate your end-of-month financial close, streamline multi-page form submissions, orchestrate CAD routines, or perhaps run extensive mobile UI tests overnight? Drop your ideas in the comments below. Give this video a thumbs up if you're excited about the future of automation, and subscribe for more deep dives into the AI tools transforming the way we work. With Utar's 1.5 at your fingertips, the only limit is your imagination. So go ahead, ask it to click, type, scroll, or drag, and watch the magic unfold. So take a deep breath, check the links in the description, and see you next time.